All right, this is Module 5, Lesson 14 homework. Today we focused on comparing different fractions using less than, greater than, or equal to, using a tape diagram, and by noticing if the numerators are the same, how you can compare that because you now are looking at the different sizes of the parts, and I'll get to that. So basically, once we get to the bottom and the back, you are looking at trying to make the numerators the same or the denominators the same using multiplication, and then that way you can have a straight up comparison. So if we look at the top here, we have 1/3 and 1/6. The important thing here is if we look at this, these written as a fraction, our numerators are the same. We have 1 here and 1 here. We're comparing 1/3 to 1/6. We know thirds are larger because there are less of them in a whole. So we are comparing 1/3 to 1/6. So we only have one piece we're actually comparing. So that would be greater than. So again, 2/2 and 2/3, if we wrote it as a fraction, we would have 2/2 and 2/3. This is a whole, and this is not. So that would be 2/2 is greater than 2/3. Also, too, you are looking at the amount of parts. You have 2 parts, but in this one, those 2 parts make the whole. In this one, those 2 parts do not make up a whole, and halves are larger than thirds. And since you have 2, it's the same way. So 2/4 and 2/6, again, if you write it as a fraction, you have 2/4 and 2/6. And if we were to look at if we looked at using some fraction stacks here, just so you can see the visual, all of these, I have fraction stacks that go up to 1/12. So we have 2/4 here, and if we look at 2/6, the whole is the same distance, okay? So this is how I was showing them. We have 1/2 and 2/6. Sixths are smaller than fourths. Since we're comparing the same amount, we know that we're just going with whichever is the largest part size, which is fourths. So that's why 2/4. And same 5/8, 5/10. Eighths are larger than tenths, and that's going to be greater than right there. Okay. Down here at the bottom, it's going to get a little tricky because we're going to have to do some conversion to find fraction equivalents, so we can look at denominators if those are different. So again, 3/6 and 3/7, we want to do 2 tape diagrams that are the same size. Okay, our whole needs to be the same size, and that's the important part. If we did our 3/6, we have 1, 2, 3, and then 1, 2, 3, 6. Okay, and then 3/7, if we were to draw the picture, again, if you look, this would be our 3/6, this is our 3/7. 3/6 is larger than 3/7, plus sixths are larger pieces than sevenths. Okay. B, they give you the example because they were actually starting to do some multiplication, so they didn't show you what they were multiplying 2/5 by, but they multiplied it by 2/2, because if we look at this, we have 2/5 is less than 4/9, but your numerators aren't the same and neither are your denominators, so we had to multiply 2/5 because we can take something and multiply it by 2 to get 4, which is 2/2, so we found the equivalent fraction of 4/10. So now we're comparing 4/10 and 4/9. So ninths are larger than tenths, and we have 4 of each. So there's that. Okay, again here we're looking 11ths, 3/11ths, and 3/13ths. We have the same amount of parts, but 11ths are larger because the number is smaller. And then here 5/7 and 10/13. You can draw a bar model here for them if you want. So it would be something like this. So let's see, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we have 5/7. 1, 2, 3, 4, 5, and 10/13. 6, 7, 8, 9, 10. Okay. Assuming this is drawn to scale, you could tell just by looking at the picture, but we're going to have to do some math. So can we multiply anything by 5 to get 10? Yes, we can. We can multiply it by 2. So we have to multiply the whole fraction by 2 over 2, and that gives us 10 14ths. And we're going to compare that to 10 13ths. 13ths are larger than 14ths, and we're comparing 10 of each. So 5 sevenths is less than 10 13ths. Again, same thing here. You're going to draw tape diagrams like we have here. Oh, I forgot. After we multiplied here, you're going to add, since you're multiplying by 2, you're going to split each of those up into 2, and then if we were to count those up, we would get 10. I'm just going to show the math here instead of doing the tape diagrams. So 3/4 and 7/12, can we multiply anything by 3 to get 7? We can't. What about 4 to 12? We can multiply by 3. So we take 3/4 and multiply it by 3 over 3, and we get 9/12 as our equivalent fraction. So we're looking at 9/12 compared to 7/12. Same denominator, so the part sizes are the same. So we're comparing the amount of them. We get 9/12. 2/4 and 1/8. Can we multiply anything by 2 to get 1/8? Or 1? No. Can we multiply anything by 4 to get 8? We can. We can multiply by 2 over 2. And we get 4/8. So we're now comparing 4/8 to 1/8. 4/8 is greater than 1/8. And then these ones here with the whole part in front of it. There's two ways they can look at it. They can ignore the 1 because that's the same, or I would prefer them to actually figure out what this total fraction is going to be. So if we're looking at this one, 1 4/10, our whole piece has 10 parts to it. So this whole is going to be 10 over 10 plus 4 over 10, and we get the fraction 14/10. Over here, we're dealing with fifths, so our whole part here would be 5 over 5 plus 3/5. We add our top, our numerator, we get 8/5. So now we're comparing 10/14 and 8/5. Can we multiply anything by 8 to get 14? Nope. Can we multiply anything by 5 to get 10? We can. We can multiply by 2. So we multiply by 2 over 2, and we get 16/10. So now we're comparing 16/10 and 14/10. And we know 16/10 is larger because we have the same part size, so we're just counting the amounts. So 16 is greater than 14. Okay. On the back, it says to draw a number line. If they want to keep going tape diagram or just show me the actual math, that's fine. So again, these are the same things. Looking 3 to 5 can't do. 4 to 8, we can multiply by 2 over 2, and that's going to give us 6/8. 6/8 is greater than 5/8. Same thing here, 11/12 compared to 3/4. Can't go 3 to 11 using multiplication, but we can go from 4 to 12 by multiplying 3 over 3, and we get 9/12, and we know 11/12 is greater than 9/12. We can't go 4 to 7 with multiplication, but we can go 5 to 10 by multiplying by 2 over 2, so 4/5 times 2 over 2 equals 8/10. So this equals 8/10, so 8/10 is greater than 7/10 because, again, we're looking at the same amount of parts, or the same size of parts with the tenths, but so now we're looking at the amount. 8 is greater than 7. This one you could do two ways. You could multiply something by 2 to get 8. You could also multiply something by 3 to get 9. I'm going to multiply 2 to 8 so we get the same numerator. So 2/3 times 4 over 4, because to go from 2 to 8 you need to multiply by 4. So that gives us 8/12. So now we're comparing 8/9 and 8/12. We have the same amount of parts, but which part size is bigger? And that's going to be the smaller number, so 8/9. Okay. These ones, again, quantity. 2 is greater than 1 because we have the same part size. Here, multiply by 2, that gives us 10/14. 11/14 is greater than 10/14. That would be the equivalent fraction. Hopefully by here they're doing them in their head. Going from 3/5 to tenths, This is going to be 6/10 is our equivalent fraction there. 10/15 is going to be that equivalent fraction because we multiplied by 5 going from 3 to 15. And then, again, multiplied by 3, so this will give us 9/12. Oh, that one's equal. Look at that. All right, same numerators, different denominators. So what's larger, thirds or halves? We know halves are larger. This one is 4/3. So we would need to convert this into a fraction greater than 1. So that's going to be 9/9 plus 2/9 because our 1 is dealing with ninths, and that gives us 11/9. We can multiply 4/3 by 3/3 because 3 times 3 gives us 9, and we get 12/9. 12/9 is larger than 11/9. And then same thing here. We're dealing with thirds. So we have 3/3 plus 1/3 equals 4/3. Here's a tough one. So now we're looking at 4/3 to 9/7. Okay, so now I'm going to do this. We have 1 1/3 and 9/7. So if we ignore our whole piece, we're left with 1/3 and 2/7. So what can we multiply 1 by to get 2? So if we multiply the 1/3 by 2/2, that gives us 2/6. So now we're dealing with 2/6 and 2/7. We have the same quantity, but now we're looking at part size. We know 6 is larger. 6ths are larger than 7ths. Okay? So now, word problem. Simon claims 4/9 is greater than 1/3. Ted thinks 4/9 is less than 1/3. Who is correct? Support your answer with a picture. So I draw a tape diagram here. So we have one is in thirds, and then the other one is going to be in ninths. 2, that's not to scale. So this one is 1/3. This one is going to be 4/9. Okay? We multiply this by 3/3, so we get the same denominator. Oops. We get 3/9. So now we're going to decompose that into smaller parts. So we have 3/9, 4/9. We know 4/9 is greater, so Simon is the correct one. Okay, so that is Module 5, Lesson 14. Hope it helps.